So good morning all. Myself Asma Sultana. I'm working as an assistant professor in computer science and engineering department in Mlritm. Today we are going to discuss about another topic in computer organization and architecture subject, that is logical gates, and it is also called as a digital logic gates. Logic gates. So these digital logic gates are the fundamental of building blocks in digital electronics, which is used to perform logical operations based on the input provided to it and gives a logical output that can be either 0 or 1. If suppose the value is 0, then it is considered as a low. If the value is 1, then it is considered as a high. Or you can write it as a true or false also. And it majorly performs the logical operations. We give the input and it generates the logical output. Logical input is given, a normal input is given. The input will be given in the form of binary form, that is 1 and 0. And the output is also generated in the form of binary, that is 1 and 0. Okay. And these logical gates are based on a Boolean algebra function or a mathematical functions. And here in these logical gates, we have 7 logical main gates. 7 types of logical gates are there. So let's see what are the 7 logical gates. So first logic gate is nothing but a AND gate. So AND gate is nothing but it performs a logical multiplication. It performs a logical multiplication of a binary input. It performs logical multiplication of binary inputs. And if suppose the two input values are high, then it is the result of these 2 input values are high, then the result will be also in a high. If suppose any of the input value is 0, then the result is also 0. So any input value is 0, then the result is also 0. Let us consider this is the graphical representation or symbolic representation of a AND gate, which is in the form of capital D. Capital D, we are giving 2 inputs. One is A and another one is a B, and we are generating one output, that is nothing but a F. So how? F is equals to X into Y. It performs a logical multiplication. If suppose A value is equals to 0 and B value is equals to, then the result is also 0. If suppose A value is equals to 0 and B value is equals to 1, then the result is also 0. If any one of the input is 0, then it is considered, the result is also considered as 0. If suppose the value is 1 and 0, then it is also 0. If suppose the values are 1 and 1, then the result is equals to 1. So this is how a logical operation is performed. A logical operation is nothing but when any 2 of the inputs are high, then the result is also high, or any two inputs are true, then the result is also true. So next logical gate is nothing but a OR gate. So OR gate is the second logical gate. So in here it performs mathematical addition. It performs mathematical addition, or you can call it as a logical addition. Logical addition, that is nothing but A plus B and X is nothing but a result. So here in OR gate the condition is nothing but if suppose any 2 input devices are 0, 0 or low, then the result is equals to 0. If any 2 of the input is 1, then the result is also 1. If any 2 inputs So one input is A, another input is B. So any of these two inputs, any of the one value is 1, then the result will be 1. If suppose the two input values are 0, then it is represented as a 0. So this is the symbolic representation or a graphical representation of a OR gate. It is slightly tilted. It is slightly in a curve model. So we provide two inputs, one is A and another one is B, and we generate a one output value. One output value in the form of binary. So what is the major condition in your OR gate? If any of the two inputs value is 1, then the result is 1. If suppose two input values are 0 and 0, then the result is equals to 0. So mathematical expression or Boolean expression is nothing but a x is equals to a plus b. A is equals to 0 and b is equals to 0, it results to 0. So 0 plus 0 is 0. So 0 plus 1 is 1. 1 plus 0 is 1. And 1 plus 1 is equals to 1. Next third gate is nothing but a NOT gate, or it is also called as an inverter gate. Inverter gate. So here it performs inversion of a input value. If suppose the input value is 0, it results 1. It will just make a opposite of your input value. If our input value is 0, then the result will become 1. If suppose input value is 1, then the output value will become 0. It is a opposite of a input value. This is input and this is your output. So this operation is called as an inversion operation. Inversion operation. So 0 is equals to 1. If 1, it is 0. And this Boolean expression is represented as a bar. So if x is equals to a, we have considered as an input as 0. So it results to the opposite of 0 is 1. So we are representing as an a bar. A bar you can write it like this or like this. So you can represent the bar in a two forms. First form is this one and second form is the another form. So what is a NOT gate? NOT gate is nothing but a inversion operation of a input value. If suppose the input value is 1, then result is 0. If input value is 0, then the result is 1. So this is the third gate. The next, the graphical representation or symbolic representation of a inverter gate, that is NOT gate, is nothing but a cross rectangle with a bubble. With a cross rectangle with a bubble, which results to a output that is nothing but a x is equals to x a bar. So only one input is given here. So for this input you are making a reverse order. And next is nothing but a fourth gate. So next is nothing but a fourth gate. A fourth gate is nothing but a NAND gate. So NAND gate is nothing but it performs mathematical multiplication. It performs a mathematical multiplication, or you can call it as an multiplication, or you can call it as an logical multiplication, or you can call it as an logical multiplication. It is similar to your AND gate. It is similar to your AND gate. For this AND gate, you are performing a negation operation. So if you perform a AND gate negation, then it will become a NAND gate. NAND gate. So the combination of AND gate and NOT gate is a NAND gate. The combination of two logical gates, one is a AND gate and another one is a NOT gate, is making as it's considered as a NAND gate. So what is the condition of a AND gate? The condition of a AND gate is if any two values are positive, two input values are positive, then it is considered a positive. So here when you perform a reverse operation for the AND gate, so AND gate truth table is nothing but it's two inputs A and B and A dot B. So 0 0 it results to 0. 0 1 it results to 0. 1 0 it results to 0. 1 1 it results to 1. So this is the AND gate. When you perform negation to this table, so what will be the result here? So negation for this one. So what will be the result? Negation for this value will be 1 1 1 and this is 0. So this is your NAND gate. So inversion operation of your AND gate. You are performing negation for the AND gate, and the symbolic representation of your NAND gate is same as your AND gate, but you are adding a small bubble to the AND gate that results to your NAND gate. So next logical gate is nothing but a NOR gate. Fifth one is NOR gate. It is same as your OR gate. So same OR gate negation operation. It is a combination of OR and NOT. NOT gate is nothing but a inverter gate. Inverter gate is nothing but which results, if suppose the input value is 0, then results to 1. If suppose it is 1, then it results to 0. Okay. So we are combining OR and NOT, then we are generating a NOR. Gate. So the Boolean expression of this one is y is equals to a plus b bar. So first we will write what is an OR gate. So two input values A and B, and OR performs mathematical addition. So if 0 0, then it is result to 0. If any one of the input is 1, then it is 1. 1 0, then it is 1. 1 1, then it is 1. So this is a OR gate classification. Now if you add NOT gate for this, the result will become 1 0 0 0. So this is a NOR gate. NOR gate. Now Boolean expression, how you will write it? So two inputs we have considered. NOR gate is in the form of curve. So sorry, this is a symbolic representation. So this will become F is equals to A plus B is a OR gate, and you are applying a NOT gate, then it will become A plus B bar. And next gate is nothing but a exclusive OR gate. Exclusive OR gate is the sixth logical gate. Here it is different from the remaining all the gates. So exclusive OR gate. XOR gate is nothing but a exclusive OR is nothing but a exclusive OR gate. XOR gate is nothing but a exclusive OR gate. So here, so what is the condition? So only one condition. If two input values are low, then the result is also low. If two input values are high, then the result is also low. So any two of the input values are same. If suppose 0 0, then the result is 0. If suppose two input values are high, then also the result is 0. So what is the condition in the exclusive OR gate? Exclusive OR gate condition is nothing but if two input values are same. If two input values are same, then the result is equals to 0. If two input values are low, then the result is also low. So here, if the two input values here also it is same, then the result is low, and remaining all will be high. So Boolean expression of this particular exclusive OR gate is equals to F is equals to xy bar plus x bar y. So this is a This is a Boolean expression. So what is the condition of your exclusive OR gate, XOR gate? If suppose two input values are same, then the result will be 0. So 0, 0 is 0, 1, 1 is 0. If suppose two input value is one is 0 and another one is 1, then the result is 1. So next gate is nothing but a seventh gate. This seventh gate is nothing but a exclusive NOR gate. XNOR gate. Exclusive NOR gate. It is reverse, it is inversion operation for your exclusive OR gate, same as a. So first we will write down the exclusive OR gate. So what is the exclusive OR gate? We are considering two input values, one is A and B, and exclusive OR gate is represented with a symbol plus with a circle, and this is B. So 0, 0, what is the condition in the exclusive NOR gate? If suppose two input values are same, the result is 0. So if suppose the 0, 1, then it results to 1. If 1, 0, then it results to 1. If 1, 1, here also the two input values are same, then the result will become 0. If suppose for these exclusive NOR gate, when we are applying a NOT gate, then the inversion operation is applied. That is nothing but a 1, 0, 0, 1. So this is your exclusive NOR gate. So what is the Boolean expression for this? F is equals to x plus x bar y bar. So these are the 7 different types of digital logic gates, and we have another gate also that is called as a buffer gate. A buffer gate represents a buffer gate. So buffer gate is nothing but we give only one input, that is nothing but x, and this buffer gate is represented with a triangle, and we generate a x. Whatever the input we are giving, that input same output is generated. Let us write a, so only one input. If suppose the input value is 0, the result is also 0. So buffer gate. If suppose the input value is 1, then the output value will also 1. So what you have, you will write the Boolean expression f is equals to x. So these are the 7 different types of logical gates. So first one is nothing but a AND gate, OR gate, NOT gate, that is also called as an inverter gate, and this is NAND gate, reverse of your AND gate. And next NOR gate. NOR gate performs NOR plus NOT, which is nothing but a NOT gate, reverse of your OR gate. And next one is XOR gate. This XOR gate is also called as an anti-coincidence gate. This exclusive NOR gate is also called as an anti-coincidence gate. And next one is exclusive NOR gate. This is the opposite of your exclusive OR gate. And last gate is nothing but a buffer gate. It takes only one input as a 0. If suppose if we are giving input value as a 0, it generates the same input value as a output. So thank you. This is all about your digital logic gates. Thank you.